Okay, so now we have an equation. Let's say E is equal to E naught sine omega t. Okay, so and then we have one more, I is equal to I naught sine of omega t plus phi. See here, E naught is the peak value and then omega t is basically the angle, correct? Right? And then here for I also, I naught is the peak value and then omega t is the angle. Now we have a phase difference. Okay, so that phase difference between E and I is given by phi. Okay, so how do we represent this in a graphical way? Okay, so we have to represent this in a graphical way. So what we do is we have something called as phasors, okay, or phase diagram. Now this phase diagram is very important as to represent the difference between E and I, how much current or EMF is leading or lagging. Okay, so let me explain what this is. See, let's say E is equal to E naught sine omega t. Now we represent E naught being the peak value as the radius of one circle. Okay, so here, so E naught is the radius. Okay, and then so this will be the circle. Now the projection of E naught on the y-axis or the x-axis, that will give us the total value of the E naught. Now see, look at the angle. This angle is omega t. Okay, so we have E naught and then omega t. Alright, then we have I is equal to I naught sine of omega t plus phi, correct? So meaning I value is more than E. See, when I say I value is more than E, I'm talking about the phase difference. Okay, now I naught need not be more or need not be less also. It could be any value. I naught, we are not bothered about I naught. But what should be considered is that angle phi. Okay, so we have I is equal to I naught sine of omega t plus phi. So this is I naught, we have a circle, and then this angle is phi. So meaning the whole angle will be omega t plus phi. Okay, so we are representing the sinusoidal wave as a circle, correct? And we are representing the peak value as the radius of the circle. So this type of diagram is what we call as a phase diagram, or in other words, phasors. Okay, so in the next coming videos, you will see how we implement phasors in representing the EMF and current for different components.